All right, in this video, we're going to be looking at our final part to this unit on conics. And so we're going to be looking at hyperbolas. Now, when we're thinking about a hyperbola, it might be hard to think where we would see a hyperbola in the real world. Well, a very simple, basic example would be what we see on the right there with the picture of the lamp. When you have a lamp with a lampshade and you put that lamp next to a wall, the resulting light that's created is actually the form of a hyperbola. So that's a very, like I said, basic way that you could look at what a hyperbola would look like. All right, so what is a hyperbola? Well, if you want, you can pause this video and read about all this, but that's just a lot of words and a bunch of mumbo jumbo. It's much easier to look at diagrams. Let's look at this next slide here. So this is a visual of what a hyperbola looks like. Now, there's some similarities and differences between a hyperbola and what we talked about previously with an ellipse. So if you recognize, the hyperbola here is made up of two arcs that are facing each other, and the focus, just like any other of the graphs that we've seen with both the ellipse and the parabola, is inside those curves. And then this has the two vertices, just like we had with an ellipse, and there's a center smack dab between the two vertices. But the only thing that's different is this: we do have a pair of asymptotes. Now again, there is some similarities and differences, so I'm going to go back and forth between this slide and might come back and reference it later. But again, this is an ellipse, and so if you notice, like I said, there's two vertices. This also had a major arc, or major axis, or a focal axis. Same thing is true for hyperbola. We also have a major axis, and it could go horizontal or vertical. Just that in this example, I'm only showing a horizontal major axis. And then an ellipse, like we see here, has a center, and the foci are inside the ellipse, where here we have our vertices, and then the foci are inside the curves. Now, one of the other things that you notice is with the ellipse, we always had addition. And when you looked at the Pythagorean relationship to find our c value is a squared minus b squared. Now, the significance of that is, so again, ellipses are always going to be adding two fractions, and the a value is always the bigger denominator. Okay, so we want to keep that straight. And to find our value for c, it was the formula was a squared minus b squared. So let's look at what we need to know for a hyperbola. So the hyperbola you see here with these general forms of the equations, we're always going to be dealing with subtraction. And if you look up here at the top, a is not necessarily the bigger value or the bigger denominator, it's the positive one. So it's whatever fraction is the positive fraction, that is the denominator, that is our a, where we're going to find our a value. Okay, now there's some similarities here where we do have a major axis. So if our a value is under the x value, we're going to have a horizontal major axis. If our a value is under the y value, it's going to be a vertical major axis. And if it's a horizontal major axis, that means that from our center, h and k, that the foci and the vertices are going to impact the h value, because again, that would refer to the horizontal value, and the y value would stay the same. If it's a vertical major axis, that means that the h values would stay the same because, again, it's not being impacted horizontally. It's only being impacted vertically, so the k values are what are going to be impacted. Also notice that here the Pythagorean relationship is a squared plus b squared. Remember, that's different from what we saw with our ellipses. With our ellipses, it was minus. So how can we keep these straight? Again, this is plus. Our Pythagorean relationship is the opposite of that. It's going to be minus. Here we're dealing with subtraction with hyperbolas, and our Pythagorean relationship, it's a squared plus b squared. So again, it's the opposite. Now this is something that's different that we haven't seen with the previous conic sections. We have asymptotes. So to find the equation for the asymptotes, there's going to be two of them. They're going to be linear. And so think about this. With the linear equation, we have a slope. And with the slope, what you're familiar with is y2 minus y1 over x2 minus x1. Similar, but we're not dealing with a difference in two y values. We're dealing with the square root, but the square root of the y denominator goes on the top, just like our change in y would go on the top for the slope, and the change of x would go on the denominator, so in this case it would be the square root of x. Denominator goes on the bottom. And that'll make more sense when we look at an example here in a second. And then that would give us basically our slope, and then it would be x minus h plus k would be the rest of our equation for our asymptote. So let's just jump right into looking at some examples. If you need to, you can pause this. This just gives you a visual of everything that we just talked about. To me, this seems cluttered, but that might help if you want to look at how the graphs would look for a hyperbola. All right, so let's look at this first example. So here we have quantity x plus 1 squared over 4 minus y squared over 9. So remember to find the a value. The a value is not, it's not the bigger denominator. The a value is whichever one's positive. So you see that first fraction is a positive one. So we know that a would be the square root of 4, which is 2. Our b would be the square root of 9, which is 3. And again, since that a value is under the x, it means that we're going to have a horizontal major axis, or a horizontal focal axis, however you want to think of it. Next, I'm going to find out what my c value is. So to find c, remember, since this is minus, it's going to be a squared plus b squared, or in this situation, 4 plus 9, which would be 13. So that tells me that c would be plus or minus square root of 13. I'm just going to write it as square root of 13. All right, so now let's jump into finding out what the center and vertices and foci of the parabola would be. So remember, the center is the coordinate h and k. So for this one, our h value is always the value that's associated with x. So we take the opposite of that plus 1, that would be negative 1. There's nothing happening with the y, so the k value would be 0. So there's your center. Find your vertices. Now remember, the vertices are on the graph. And the graph would be made up of coordinates that would be from our equation. So I like to think of it that way because that helps me figure out what are we doing here with our A or C value. So since our A value, we got that directly from that equation, that's going to be a point that's going to give us points directly on the graph. So that'll give us our vertices. So since this is a horizontal major axis, it's going to be the x values that are going to be impacted by A, but our k value would stay the same. So in this case, our h value is negative 1. Our a value is 2, so it'll be negative 1 plus or minus 2. Our k value, which is 0, stays the same. So we're just going to simplify this. Negative 1 plus 2 would be 1. So one of your vertices would be at would be at 1, 0. And the other one, negative 1 minus 2, that's negative 3. So negative 3, 0 would be our other vertex. And then to find your foci, again, it's going to be a coordinate. And it's not on the graph, so we're going to use a point that we didn't get directly from the equation, but the c value, we use that equation to find our c value, so we're going to use that to find our foci. So it'll be h plus or minus our c value. Again, our k value would stay the same. So this we can just write as negative 1 plus or minus the square root of 13. And our y value would be 0. So those would be our two coordinates for our foci. Those are the three answers that they asked for, but the one thing that we're going to do in addition to those three is I do want to talk about how you would find the equation for the asymptote. So this is going to have a pair of asymptotes. So remember, the equation is going to be y equals plus or minus. Then we're going to take the square root of what's underneath the y value. So the square root, so 9 is under the y, so the square root of 9 would be 3. And that's going to be on over what's the square root of under the x value. So the square root of 4 would be 2. So we get plus or minus 3 halves. And then it's going to be x minus our h value. Our h is negative 1. So x minus negative 1 becomes x plus 1. Then we plus k. So if you want to write down plus 0, you can. Otherwise, we can just say y equals plus or minus 3 halves x plus 1 would be our equations for our two asymptotes. All right. So I want you guys to try the next one completely on your own. Again, it doesn't ask for the asymptotes, but please, I want you to make sure that you find the asymptotes in addition to finding the center, the vertices, and the foci. So I want you guys to go ahead and pause the video and hit play when you're ready to check your answer. All right, let's see how you did. So here you can see that this one, since our first fraction there, that's positive, is dealing with the y, so that tells us it's going to be a vertical major axis. So our a value is 3, our b value is 2. Our center would be at the coordinate 5, 3. So make sure that you look for where the x is to find the h. So remember, the h is the opposite of what happens with the x. So make sure that you're aware of that you don't be tricked by accidentally just taking the opposite of the first term. And then we can figure out what our c value is as well. I'm going to skip down there in green. So to find our c value, because we're going to use that for the foci, so it'd be c squared equals our a squared plus b squared, so 9 plus 4, or square root of 13, would be the same thing that we had in the previous example. And so we use the foci again to find we use the c value again to find the foci. So it would be, since it's a vertical major axis, it's going to be the k that's going to be impacted this time. So it'd be the x value or the h value stays the same. So it'd be 5, and then it would be 3 plus or minus the square root of 13 to get our foci. And then to get your vertices, since that is on, your vertices are on your graph, we get that directly from our equation, which would be our a value. So again, this is being affected vertically, so the h value stays the same, but the k value, we would use our k value to find the y values here for our vertex. So we would have 3 plus or minus our a value, which is 3. So 3 plus 3 is 6, and 3 minus 3 would be 0. So those would be our two coordinates for our vertices. And you can look at the graph there if you want to see how that would look when you put that all together. But let's talk about our asymptotes. So again, we take the square root of what's underneath the y values. The square root of 9 is 3. Over the square root of what's under the x value. So the square root of 4 is 2. So we y equals plus or minus 3 halves. And then we x minus the h value. So x minus 5 plus your k value, which is 3. So hopefully you got all that for that problem. Now remember, from when we looked at ellipses, there's going to be times where it's not written in that form, and we want to get it in that form. So then that way we can easily find the center, vertices, and foci and asymptotes of the graph. All right, so let's look at how we would do this one. So we're going to use completing the square, just like we've been doing in the past. Now for these, we can see, again, we have two squared values. I always like to start with whichever one is positive. So in this case, it would be the y squared that's positive. So I'm going to start with that one. So we're going to pair with that any other y values. So we'd have 64y squared minus 512y. There is going to be something that we're going to add there eventually. And then we have our x squareds. Okay, so I'm going to have minus 36x squared minus 216x equals, and then we're going to have this number here. We're going to get that to the other side. That does not have an x or y attached to it, so we're going to separate that. So we're going to subtract that from both sides, so we get negative 3004. All right, so let's go back to the beginning. Remember, in order to complete the square, we need to make sure that our squared term doesn't have a number in front of it. So if it does, we're going to factor that out. So we're going to factor out a 64. So when you do that, now granted you'd be able to use your calculator, but when we factor out a 64, or take 512 divided by 64, we would get 8. So it'd be y squared minus 8y plus something. And let's go to the next one. So do the same thing. We want to get rid of the negative 36. I'm going to factor out a negative 36. So we get the x squared by itself. Now when I take negative 216 divided by negative 36, that gives me a positive 6. So it'll be plus 6x. So then we're going to add something here. So negative 3004, and then we're going to add two values here. So to figure out what we add, now let's go back and complete the square. So in that first set, remember we take half of our b value, so half of negative 8 is negative 4. We square that and we get 16. Now the problem is I'm not going to put 16 over in this other blank. And the reason why, remember, is because that 16 really has a value of, oops, I'll do it this way, of 64 times 16. So we're going to take 64 times 16, and then we're going to put that value over here. So again, you'll be using your calculator. 64 times 16 is 1024, so that's what we would add over in that other spot. Now let's do the same thing with that next set, the x terms. So half of 6 is 3, and we square 3, we get 9. But again, we don't add 9 to that other spot. We're going to take negative 36 times 9, and then that's what we put over on the other side, and that's going to be a negative 324. All right, so now let's look to see what this will be when you simplify it. So that's 64, we're just going to keep that. And then to complete the square, we take half of our b value, so that's just half negative 8 is negative 4. So it'll be y minus 4 quantity squared. And then it'll be minus 36. It's going to be half of 6 is 3, so it'll be x plus 3 quantity squared equals, and when you simplify that right side, negative 3004 plus 1024 minus 324 gives you negative 2304. All right, so now what we're going to do is to simplify this, we want to get this equal to 1. So I'm going to divide everything by negative 2304. So both of these terms, I'm going to divide by that value. All right, so when you do that, again, you'll be using your calculator. When I take negative 2,304 divided by 64, that's going to give me a value of 36. So we would have y minus 4 quantity squared over negative 36, I should say. And then when we do this next one, a negative divided by a negative is a positive. So now this is going to become plus. So negative 2,304 divided by negative 36 will be a positive 64, and then this would equal 1. Now you could technically leave it like this, but I just want to be consistent with what we've seen in the previous problems, because if you notice, the second fraction is a positive one, the first one's negative. So let's rewrite this. So again, either one of these would be correct. So, but I'm going to rewrite this to be x plus 3 quantity squared over 64. Going to be minus y minus 4 quantity squared over 36 equals 1. I do like that one better, but again, either one of those would technically be correct. Now, we could take the time now to find the center vertices, foci, and asymptotes of that equation, but I feel like you've had enough practice with that. So I just want to make sure you know how to create this equation. So go ahead, and I want you guys to try this next one completely on your own. So go ahead now and pause this video and hit play when you're ready to check to see if you've done it correctly. All right, let's see how you did. So you should have gotten, so if you want to pause this and follow my work, you should have gotten y minus 1 quantity squared over 9 minus x plus 3 quantity squared over 25 equals 1. Now, if you didn't take the time to find the center, vertices, foci, I didn't have space for finding the asymptotes, so if you didn't do that, that's fine. But that is, if you need to go back and review how to do that, it might be good to look at. So that's it. So hopefully you have a better understanding now of how to work with hyperbolas, which is this last section on conics.